I'm going to show a couple problems here. For this video, we're just doing number 11 from 3.2, and it's the integral of the square root of cosine x sine cubed x dx. And so this is going to be a substitution problem, but we're going to do a kind of combination substitution and looking at some trig identities in here. And so in doing a substitution, the thing we really can't get away from is the fact that we have a cosine here under the radical. I don't know why that's not blue. Looks kind of black to me there. Oh, okay, that's blue. So we have this under the radical, we have the cosine function. So if we were to say u equals cosine of x, then our du would be negative sine x dx. And I could do something with this negative sine x dx. In fact, I could rewrite this as integral of the square root of cosine x times sine squared x times sine x dx. And by the way, with this negative, I'll just call it negative du equals sine x dx. And so I have this part that represents my negative du. So that's good. And then I can have a u under here for the radical, under the radical. And so the question is, what do I do with this sine squared x? And this is where we go back to our trig identities that we had: sine squared x plus cosine squared x equals 1. And if we solve for sine squared x, we get 1 minus cosine squared x. So I could put this in place of the sine squared x, and now I have everything in terms of cosine. And I guess evaluate in terms of cosine, or I could do u substitution, which I'm not sure would be easier for people to see, but I'll just do a u substitution when I get to that point. So we have the square root of cosine of x times 1 minus cosine squared x times negative sine. No, I'll deal with the negative in a minute. I just said sine x dx. So I kind of wanting to do that now, but I'll just do like I said. You'll see how that changes things a little bit. Okay, and again, this is my du here. Negative du is this part. And I can't make that little, there we go. And I can rewrite this square root of cosine as cosine to the 1/2, or cosine x to the 1/2. And I'm just not writing things very clearly today, I apologize. So cosine to the 1/2, cosine x to the 1/2, times our 1 minus cosine squared x, then times the sine x dx. And now if I were to change things to the u's, I have the integral of the square root of u times 1 minus u squared, I should say, u to the 1/2. 1 minus u squared times negative du, let's say negative 1 du. And this plays in to affect the order here. So this negative here, I'm going to change that there. So I'll have the integral of u to the 1/2 times u squared minus 1 du. So I end up with the integral of u to the, now it's a 1/2 plus 2, that makes it 5/2 minus u to the 1/2 du. And the antiderivative for this, just the power rule, it's pretty straightforward. It's u to the 7/2 over 7/2 minus u to the 3/2 over 3/2 plus c. So to clean it up a little bit, it's 2/7 u to the 7/2 minus 2/3, excuse me. No, yes, minus 2/3 u to the 3/2, confusing myself here, plus c. So what was our u? It was cosine. So it's 2/7 cosine of x to the 7/2 minus 2/3 cosine of x to the 3/2 plus c. Now, I noticed one person wrote this in their answer. I gave the points to them because they wrote it correctly, but just the way the computer accepted it was different. They seem to want it, the cosine functioned in parentheses, and then the powers listed afterwards. So that function to that power. So just be aware of that when you input this problem. If you get it wrong and it's in the right format, I mean, it looks right, let me know, and I'm happy to give you those points. Okay, hope that helps.